In the last video, we learned all about the core structure of the amino acid. And the pieces of an amino acid are going to be very important for you to recognize. Anytime I ask you to look at any amino acid, I want you to find the alpha carbon. In fact, it helps to circle it in that fashion like we just did there. Once you find the alpha carbon, or how do you find the alpha carbon? Well, it's a carbon that has a nitrogen attached to it, in this case by an amine. It has a carbon attached to it as part of a carboxylate. It has a hydrogen attached to it, and it has then a variable group, which we haven't got to yet. That's your core amino acid structure. And at this point, we'd like to point out that before we move on to these variable groups, we need to address one more issue about the core structure, and that is its ionization. The ionization is something we've already covered in a previous unit. That is, how do we know when something is protonated or not? And the answer is always going to be knowing the pKa of a functional group and knowing what pH we are at. So let's consider pH 7, the neutral pH that we have in most tissues, including the blood and cells and things like that. What would we expect for the ionization state? Now let's remember, the first thing we need to do is assign the pKa for functional groups. If we look at our carboxylic acid up here, we would say that the pKa is in the 2 to 5 range. And if we look at the amine, we would say that the pKa is in the 8 to 11 range. Now, take a look at pH 7 and remember the rules we used. If pH 7 is greater than the pKa, or on the basic side, as it is for the carboxylic acid, we're going to have that functional group in the basic form. That means the deprotonated carboxylate that we see right here. How about the amine? The pH of 7 is on the acidic side, or beneath the pKa range 8 to 11. That means it's going to be in the acidic form, or protonated form, and we've drawn it as NH3 plus here. I want to make a quick note here, by the way. There's something I'm doing that's not quite technically correct, and that is the pKa of this amine is not really 8 to 11. It's the pKa of the protonated amine that's 8 to 11. Amines can be neutral with a pair of electrons like we see right there, or they can pick up a proton and be positive. These are the two forms we have. This is the basic form, and this is the acidic form. So when I say the pKa is 8 to 11, I'm really talking about this form over here, and our decision about whether it's protonated or not has to choose between those two forms. So that's a little unusual because we're actually giving a proton back in this case to make it NH3 plus. Because this pH 7 is the common pH that we would expect, kind of a neutral pH in our body, we're going to typically draw amino acids in this form. Carboxylate, negative charge, NH3 protonated amine, positive charge. And that's an interesting species because it has both a full positive charge and a full negative charge. There's something special we call that type of molecule in biochemistry. We call it the Zwitter ion. That's German for inner salt. And what that is at least one positive and negative charge on a molecule. It doesn't have to balance. You could have two positives and one negative. That would still be a Zwitter ion as long as you have one of each. So I'd like you to know that term. Now, this is the common form we're going to draw amino acids, and this is going to be the default. Unless I give you an unusual pH, I expect you to draw the amino acid core structure with this Zwitter ionic form. And we're going to see that, and I'll make note of it going ahead in the next few videos. And we're ready to move on to the next videos in the next few pages. And to introduce that idea, I would like to tell you that we are going to talk about the variable group, the R group. This is going to go from one amino acid structure to 20 different amino acid structures. And as an introduction to that, I would like to tell you that there are 4 classes of amino acids. And I'll introduce those 4 classes right now. First of all, there are the nonpolar. Second of all, there's the polar neutral. Third, we have the polar positive. That is charged positive. And fourth, we have the polar negative, as you might guess. So that's a good introduction. The next 4 videos are going to be taking each one of these classes one at a time. So we'll start with the nonpolar in the next video.